And he's the leader of the Neuroinflammation, Pain and Fatigue Lab at the University of Birmingham in Alabama. Unlike many of us, he actually began his career in MECFS and he's continued to work in that area. He now runs quite a large lab and he has several projects on the go. Most of these are involved around neuroinflammation and the microglia. And today we're going to hear about some of the research that's been done in his lab. So I think if we next now.
Hi, I'm Jared Younger. I am director of the Neuroinflammation, Pain and Fatigue Laboratory, and that's at the University of Alabama, Birmingham, in the United States. Unfortunately, I wasn't able to make it to be there with you, but I am able to talk a little bit about what our lab is doing right now and what you can expect to see from us in 2019. So I thought I would take about 10 minutes or a little bit less to talk about the projects that are most pertinent to MECFS, particularly the ones that are looking at new diagnostic tools and new treatments for the disorder. So you might have seen the first one that came out this year from our lab. This was a brain inflammation study that was published, I think, about 5 weeks ago. And we were using magnetic resonance spectroscopy to look at signs of inflammation in the brain. And that one worked out really well. It supported our hypothesis. We found several regions of the brain all over distributed throughout the brain where there were signs of neuroinflammation. In particular, we found something called lactate. And lactate is something that you should not see in a brain normally. It usually is only produced when there's so much activity that it overwhelms the blood's ability to get oxygen to that region. And that should not happen with just normal mental processes. It usually happens when there's inflammation. So we found lactate distributed throughout the brain and other markers as well. And that strongly indicates brain inflammation in MECFS. Now, other groups have reported that as well. And we're probably the fifth, this is probably the fifth paper to show evidence of brain inflammation in MECFS. And so now I think we've got some very, very credible, repeatable information showing that MECFS somehow involves brain inflammation. And the reason that's related to the symptoms is that when you have inflammation in the brain, the chemicals that are produced, the number one symptom they cause is profound fatigue. So the symptoms of MECFS fit with brain inflammation very well. And then when we do the imaging, we see evidence of inflammation. All that comes together to suggest that that may be something we're targeting. So we put out that paper, and it, as did others, show the evidence of brain inflammation, but it was too general to tell us why people with MECFS have brain inflammation. We don't know if the brain inflammation is the cause of the problem or if it's the result of the problem, and it's important to figure that out. For example, you could have brain inflammation because you have an infection. It could be a bacterium, it could be a virus. You can have brain inflammation because you have an autoimmune disorder or because there's some other kind of immune dysregulation. And so we've got to figure out which one of those is the case, because all of those would be treated in very different ways. You'll treat a virus infection a lot different than you'll treat an autoimmune disorder, even though both involve brain inflammation. So our next studies are going to be figuring out why do people with MECFS have brain inflammation, and what specifically do we need to target to reduce the symptoms or to reverse the disease. So several projects are ongoing this year to do that. One is we just received funding from ME Research UK, so that's a United Kingdom-based nonprofit for MECFS research. They gave us money to test a very specific hypothesis about why there may be brain inflammation in MECFS. What we're going to do is pull blood from people who have MECFS, and we're going to put a tracer in their peripheral immune cells. So our body has cells called T cells and B cells, and those are the cells responsible for fighting off infection. Our brain has different cells. They're called microglia, and they do the same job, but these are different cells, and they're not supposed to really talk to each other. The T cells and B cells work in the body, the microglia work in the brain, and they're separated by the blood-brain barrier. What we think may be happening is that for some reason, those peripheral immune cells, T cells and B cells and a few others, have been allowed access to the brain. They've either broken through the blood-brain barrier or a gate's been opened. And once those cells are in the brain, in a place where they're not supposed to be, they react poorly to that new environment and they release these pro-inflammatory agents and signalers that cause an inflammatory process and eventually cause very, very profound fatigue and other symptoms. And so this test will allow us to trace those cells for the first time in humans, scan them multiple days later to see if those labeled, those tagged cells have made it into the brain. If we see that, now we don't know if we're going to find it or not because it's never been done before, but if we do see that, it's going to be incredibly powerful information about what specifically may be wrong in ME/CFS. It'll give us some really good targets. If we don't find it, then we will test other reasons why someone may have chronic brain inflammation. We're doing another PET study or positron emission tomography study. We're starting that right now. That is looking at a new chemical or a new, I guess we call it a tracer or a ligand that shows microglia when they're in their activated state. So microglia can be in their resting state where they have a bunch of long processes. That's when they're not causing any symptoms. When they become activated and inflammatory, they change shape, they become very circular, and they start to pump out a bunch of chemicals that can make you feel horrible. So this new positron emission tomography tracer can show us which state those microglia are in. And so we're going to do that in fibromyalgia and eventually in ME/CFS to see if we can find evidence that the microglia are dysregulated. And that can give us another target for treatment because there are drugs that can be developed and given to individuals that will cause the microglia to go back into their natural state. So a lot of brain imaging stuff. We're going to be doing a lot of that this year. So expect to see some papers in 2019 on that. We're doing a lot of blood studies as well. This is another approach to getting at the problem of ME/CFS. So we published a paper a few years ago where we, and I don't think anyone else does this, we took blood draws from people with ME/CFS multiple days, like 25 days in a row, and then we had them rate their fatigue. And so when you look at your fatigue, there's ups and downs of fatigue over the days. We could measure things in the blood and find out what matched with the ups and downs. And in almost every case, those were inflammatory things in the circulating blood. And so we reported that when you have a bad fatigue day, that is related to something happening in the immune system. Now, that was a really small study, but we were able to get a grant, and now we have that information on many, many, many more people in a much larger list of things we're looking at in the blood. And I have all that data in my possession now, and so now we just have to do all the work of analyzing it, interpreting it, writing up the papers, and getting it out. But you should see several papers in 2019 on looking at the blood to see what is wrong in ME/CFS, particularly looking at different types of inflammation and trying to figure out what group has an autoimmune problem, what group has an infectious problem, what group has an immune dysregulation problem, and what group has something else, maybe a hormonal issue or something with neuropeptides. This process will allow us to separate into subgroups the overall ME/CFS population. I think it's going to be really important, and you probably hear other people talking about that because it is very, very unlikely that everyone with ME/CFS is suffering from the same problem. It is multiple causes that probably all lead to brain inflammation, but for different reasons, and so we have to target it in different ways. The last kind of group of studies, so we've got the brain imaging, we've got blood tests. The last group is the clinical trials. Now, we do not have funding to run any clinical trials in ME/CFS right now, but we are wrapping up trials in Gulf War illness and fibromyalgia. And those are conditions I think overlap in terms of their mechanism with chronic fatigue syndrome. So I still think they're informative. We are going to finish a low-dose dextromethorphan study, which is a drug that can calm down microglia and maybe help brain inflammation without causing a lot of side effects. That's in fibromyalgia. When we finish that, if that's successful, then we will try to do that in ME/CFS next. We also finished a trial of 9 different botanical anti-brain inflammation agents, things like stinging nettle and what else do we do? Curcumin, resveratrol, boswellia, a few other agents. We tested 9 of those in Gulf wearillness, and that's a condition that looks a lot like fibromyalgia and chronic fatigue syndrome. We're still trying to figure out what's going on in that condition. Out of the 9 agents we tried, at least 3 of them were very effective, maybe 4 of them. I'm still doing analyses. But once we have that final list of botanical agents that calm down pain and fatigue, we can then try those in chronic fatigue syndrome and see if it also helps that condition as well. So that's the positive thing about doing these studies in these other conditions. We're also planning some new studies, and we're trying to get funding for different clinical trials for ME/CFS. So one is non-invasive vagus nerve stimulation. So now there are non-invasive ways to stimulate the vagus nerve. And in addition to kind of correcting sympathetic parasympathetic nervous system balance, it also calms down brain inflammation. And so it is possible that it can help chronic fatigue syndrome. We won't know until we test it, but that's kind of at the top of my list to try. We may also try brain cooling. And so there are devices that you can put on your brain and around your neck that cool the brain off. And that may be useful because we found in the study we put out a few weeks ago that the ME/CFS brain is running a bit too hot, and that may be related to the neuroinflammation. And it's possible that cooling down the brain will correct some of the symptoms and maybe even stop the disease process. We don't know, but it's something that may be worth trying. We're also developing new compounds, and so we're trying to create an improved version of low-dose naltrexone that may work much better than the standard low-dose naltrexone that people are taking now for brain inflammation. So we have a lot going on. It keeps us very busy, but we are progressing on many different fronts. This year in particular will be a very active year because we've spent the past 4 years collecting data, and now it's time to get all that information out. So you should see a lot coming out from us. If you want to stay on top of it, you can find us on Facebook, or you can find us on YouTube, and I try to post things as new findings come out. In both cases, all you have to do is type in neuroinflammation, pain, and fatigue laboratory, and our laboratory will come up first, or it'll say Younger Lab, and you can track us that way. So we will continue working, putting out the information, and we've got some very good leads, and we're going to follow those out, see what's most important, and really try to get out those diagnostic tools and those treatments so physicians have something to work with, whether it's a primary care physician or a specialist. So that's what we're doing, and that's the update. I hope in a year we've got a lot of big advancements that I can talk about, and I hope the rest of the conference goes very well. Thanks.